Well, good afternoon. My name is Eric Heiser, and as you see up here, we're going to be talking about dynamic testing to minimize supply chain risk. But what does that really mean? What are we going to talk about? Ultimately, we're going to take a little journey through what's really happening out in the supply chain. How do we understand this? How do we translate this into something that we can use earlier in our design process? How do we kind of predict these potential hazards? And then how do we evaluate against those? So again, it's just going to be this journey through a supply chain to give a better understanding. It's really applicable to a lot of folks. Typically through ISTA, we're talking to packaging folks, but the content in here is applicable across a broader professional discipline, in that there's other folks who can influence along the way, and we'll kind of get into that and talk about that. Before we dive too far in, just to give everyone a little bit of understanding of who I am and where I came from, to give you some grounding on context here. I am a product of the School of Packaging from MSU. Once I started into my professional career, I worked for several years for UPS in their package design and testing lab. There we really uncovered a lot of different goods and bads with all the customers that UPS has. So that was a good opportunity to kind of put those pieces of information in my toolkit. And I took those along with me when I moved into a consumer goods role at the Scotts Miracle-Gro company, where I was leading a small global team responsible for all packaging of the Miracle-Gro brand, which was an exciting adventure to be able to design packaging for a market-leading brand. And so pulling all that information together, all that history and background, really put me in a good hold to start my career with ISTA. And what ISTA is, the International Safe Transit Association. For those folks who don't know who we are, I oversee all technical aspects of the association. I think you'll get a better understanding of who ISTA is here in just a second as we move into a short little video. Bear with me, I'm going to swing the mic down to the computer so you guys can hear the video. One additional just housekeeping note: lots of good information here that we're going to cover today. When we're done, certainly I'll address any questions you have. If we don't get to them today, we do have a booth here at the show today, and would more than welcome you to come over and kind of talk about your specific questions or needs.
Since 1948, our nonprofit member-driven association has led the industry in developing test protocols to ensure products survive the risky and hazardous global distribution market. The risk of damage is present in every supply chain, but transportation hazards are predictable, and damage can be prevented. ISTA provides solutions for engineering packaging that meets the demand of their supply chain at the lowest cost and smallest environmental footprint. The proven credibility of our test protocols and design standards provide the confidence needed in managing risk while optimizing your supply chain. Through the collection and development of this important data, our testing protocols offer a level of assurance and set a standard for manufacturers, distributors, and testing laboratories worldwide. With international input and a consensus-based approach, our testing protocols and design standards define how packages should perform in transit. We anticipate the needs of tomorrow for our global member base that includes product manufacturers, packaging suppliers, package carriers, testing laboratories, and research and academic institutions. The unique offerings of an ISTA membership include certification, Certification programs for testing labs, packages, and people provide our members with industry-recognized third-party credibility. Knowledge. Our extensive worldwide network of resources and technical support keeps members at the leading edge of their profession and industry. Networking. Forums, workshops, and symposiums provide you with the professional development and interactions you need to stay current and connected. Education. Members have access to education in responsible and efficient packaging design through courses developed by the industry's leading experts. Join ISTA to gain knowledge, credibility, and confidence to reduce your costs and environmental impact while minimizing your supply chain risk.
So this is kind of a recap of the highlights of the video. I think the video does a really good job of kind of giving a basic understanding of what the association is really all about. They've been around for quite some time. They definitely are the global authority when it comes to test standards for packaged goods, pre-shipment testing. Ultimately, and then we'll get into this with the, for the vision and the mission, but the basis of ISTA is to better the industry, right? Bring people together for a common purpose, common good, and we kind of help facilitate that improvement of the industry by providing members the information and the data that they need, that it's up to date, so that they have the confidence that they are designing to the most current standards out there. So that's ISTA. That's who we are and what we're all about. But now let's kind of shift gears a little bit and talk about the role of packaging. We'll just kind of start building from here through the conversation today. Packaging is something that has been around for a long time. Its early kind of use was more of a tool to help get something somewhere, right? Think wood crates, think back railroads and wood crates and straw and popcorn and all that stuff. And packaging as an industry and as professionals have been long trying to get a seat at the table during product design and development. They've been trying to pull themselves further up, and what you see across the bottom here is more of a traditional development process, design process, staging gate, however you want to refer to this design process. They've been trying to move themselves further up rather than just this vehicle to get the product to the consumer. So, in my opinion, I think the packaging has done a really good job and really brought themselves to the table during the design process, working closely with the product designers. And they've done that through a couple different means. One being that the packaging offers a functionality. So you start thinking about trigger sprayers, squeeze ketchup bottles, different ways that people can interact with the product has really enabled packaging to be a critical part of that product design. And additionally, early on marketing found that while they can use packaging as a tool to drive purchase intent, we can make it look shiny, flashy, sitting on the store shelf, lure people over. Through that development of packaging and becoming a little bit more diverse, it created subsets of packaging. And the terms that are used in the industry are kind of primary packaging, secondary, and tertiary, and they go along the lines of direct contact with the product and then move further away from the product. This kind of primary, secondary, and tertiary, because its packaging is diverse, has lended itself to have different places throughout the design process, as you see here. Primary packaging got that, packaging got the seat, but then it started getting divvied up, and primary packaging holds the seat at the design table. That's where all the sexy things happen, and later on we started thinking about, well, now we got this cool little trigger bottle and we're going to put it into maybe a tray with an HSC because it's going to go on the store shelf and it's going to look nice. And then, well, we got to get it to the store. Well, we'll just put a whole bunch of them on a pallet and we'll ship it out the door. This kind of progression down the path is pretty typical, and unfortunately, those things that happen at the end are done at the last minute, done without change, and can wreak a lot of havoc. So in my experience, all the time was spent on the front end, getting the primary package just right, and then we didn't want to change scope, timelines, things like this, so it was like, well, let's just do an abbreviated testing scenario. Let's just see what happens. If we get the results, they're semi-favorable. There was no time to change. We're just going to accept it and move on. And so I think part of what I want to impress on everyone today is, much like primary packaging has got a seat at the primary table or at the design table, I'd like to see the other facets of packaging be brought forward, because the future of packaging is changing. Packaging is kind of ever evolving as this buzzword of e-commerce is thrown around more and more and more, and people are starting to kind of head down those paths, those new business endeavors. These terms or means of utilizing packaging are changing. So driving purchase intent through packaging is really going away or significantly changing. People are buying online, so they're seeing videos and detailed pictures, and they're purchasing the package or the product, and then they're receiving it at their home. There's no need for it to be flashy anymore. They've already purchased it, so now when it shows up at your doorstep and it's a little rough, a little beat up, what's that saying about your product? Is the consumer assuming that, well, they didn't care about the packaging, the product's probably a cheap product. Conversely, we've all seen or experienced those stories of a great big box and a little bit of product inside that came from an e-commerce retailer. It's like, these people don't care about sustainability, they don't care about the environment. So ultimately what I'm trying to say here is, packaging as a marketing tool is evolving, at least within the e-commerce space. It's also evolving when we talk about the functionality of packaging. So packaging now takes on this arena of protective packaging, right? That's functional. The functional aspect is that it's going to protect the package or the product through its journey. Here's a couple slides. There are screenshots that I took from last month off the web, just to really showing that this evolution is happening. It may be small for the folks in the back, but U.S. Postal Service ramps up same-day grocery delivery service. Amazon to test package pickups on public transit. Target Corp to test home delivery for grocery e-commerce. So it is something that is real. I think everyone's wising up to the fact that you can't take your existing product, slap a label on it, send it out the door, and your consumer is going to have the same experience. So we kind of laid that foundation about packaging. Is there a need for protective packaging is now the question. So again, we want to try to bring a lot of this stuff to the earlier part of the conversation. And there is a need for protective packaging for numerous reasons, but we start talking about things not being consumed where they're made. And I think a big one on this slide here is this second bullet of Primary packaging has been part of the conversation for a long time, and now is a source of opportunity to lightweight or alter design without really understanding the downstream implications, because they weren't aware of what is out in the supply chain, the hazards associated with the supply chain. So I want to just give you kind of another look at the basic concept of protective packaging, kind of in a visual state versus words. So a supply chain has a certain intensity associated with it. If your product is, say, a steel bar, it's likely not going to need any packaging, right? It's robust enough to surpass the intensity level of that particular supply chain. So no packaging needed. If you got something that is maybe more fragile, light bulbs is a drastic example on the other side of the spectrum here. The product itself cannot sustain the intensity of the environment, so we need to add some packaging to it to get it up to that intensity level. Well, if you design the packaging system to have a little too little of packaging, you could be in this scenario where you're not intense enough, you're not robust enough to meet the intensity of the supply chain, and you're going to have damage. Or you could go overkill, and you'll survive, but you're throwing away money. And lastly, this is a pretty important one to consider as well, is that there's some things that can be done to the product that will enable it to utilize less packaging. So you can change how the product is configured if you have that influence or that power, but changing some components, beefing things up on the product could and will result in using less packaging and get you where you need to be. So, a recap, right? These are the things that I just discussed and talked about, but it's really understanding what's going on out there in the real world so that you can marry your package and your product up to that intensity level. And you see on here, this kind of packaged product is something I'll refer to quite a bit. It's what ISTA refers to when we're talking about a packaging system, is that package and that product, they work together. They're not individual items. So what do we need to prepare for? We got an understanding of there's some scary stuff going on out there, but what does that really look like? Typically, I can ask these couple questions and I'll get some answers, maybe no answers, but really it's all about asking questions so that you can understand. A lot of folks have trouble understanding what happens inside their facility, and if they have a grasp on that, then you drill to the next layer of what happens if it leaves your facility. What if it leaves your control? A lot of people are using 3PLs, third-party logistics, and other distribution centers, and everyone's retailers are evolving. What do those environments look like? Home Depot just went through something a few years ago with their rapid deployment. So they went from kind of a few large distribution centers to these several smaller ones closer out to the stores. Now we got more touch points, we got more handles, we got more things going on. So hazards do exist. Here's a look at it, what a potential scenario could be that is hazardous. But, that's a real picture. So are these, but these are kind of extreme. And the previous picture is on the kind of the high end of normal. That they shouldn't let those packages build up like that, but that does occur. When we start looking at stuff like this, it's more catastrophic. Is it realistic? Yeah, because we see pictures of it, but it's something that you shouldn't have to prepare for. And that's really a key point here is you need to prepare for what is normal and not be preparing for the worst case scenario, catastrophic, because you're going to end up having too much money in your packaging. There needs to be some ownership on all parties, including the carrier. So, what is more typical? More typical is compression. You know, everyone starts thinking about the hazards that are out there. Everyone's familiar because it's typically in their backyard is the warehouse. We got vertical compression going on. Things are stacked up. I understand that. I see that. I know it. But there's other things happening too that are still in that kind of common knowledge of forklifts and clamp trucks and things like that. I think those are all critical, but we can drive a little bit deeper to understand those elements that are critical. So, in my estimation, there's 4 primary hazard elements that need to be considered. Shock. Which shock, for those who maybe are thinking along different lines or solely about drops, a shock can happen in a couple different ways. It's a force that happens onto a package, so it may be another package that collides into it, similar to what we saw earlier in those pictures. There's the vibration piece, compression as we talked about, and then the climatic effects, atmospheric. So as we look at those 4 individually, we start looking at shock. So we'll talk about shock in the parcel distribution, which is kind of the UPS, FedExes of the world. You know, it does happen when packages are dropped. This is kind of what I was alluding to earlier. It's when packages strike each other. There's sorting that happens. Even though this is centric to the parcel delivery system, it's still applicable across the broader set through other distribution channels. Here's a look at package handling from an earlier time. And as you'll see as we click through some other pictures, things have gotten better, but some things are still going to be basic. So as ISTA and other folks look at the environment, we analyze it, we gather data on it, we're really finding time and time again that there are more low-level shocks. So things are happening to packages several times, but they're at this lower intensity. It's not what was thought of previously as, you know, I'm going to go throw my package off the 2nd story of my building one time and that should cover me because that's the worst it could be. When in fact there's actually a lot of these smaller nudges, bumps that are going on. And you can see here, this is kind of from the data to show supporting the fact that, you know, big high intense drops or shocks don't really occur. And as we kind of dive into the data a little bit more, we continually see that you know, it's happening to a base, meaning the kind of the bottom, the largest face of a package, and it can happen in any direction. So here's an example of a sorting facility where the packages are transitioning into a loading area. So they're going down these mechanical sorters, they're colliding into each other. You know, those are shock forces. And here's the picture that I was referring to earlier that is somewhat similar to the old picture. You know, it seems to some folks appalling when they see these pictures, like how is this happening? Why is this happening? Unfortunately, it is still a reality, and you can try to not prepare for it, deny it, but orientation is not going to be guaranteed. There's still a lot of things that are going on out there that are more rudimentary, basic. Just some more examples kind of illustrating those points. So when we talk about shocks, like as we start trying to understand the supply chain so that we have this knowledge to apply to the conversation when we're designing and developing products, shocks can happen in a lot of different ways, and they're different for each product and package. You take example of a flat package, that's going to be more prone to impacts and shocks on that large face. So if you're thinking along those lines based on your product, what it could look like, you know, being prepared for a potential hazard impacting the center of that package is a reality. Additionally, if you have a package that is long and slender of nature, the reality is that it could impact or have other packages impact it into the center. So you need to understand that as a risk and start preparing for it. So as we continue on this shock conversation here, we start talking about tractor trailers bumping over a curb. Doesn't seem that drastic, but it can really impact the stability of your load, as you see down here in the lower pictures. And those are scenarios that happen all the time that can take a long time for people to dig to the root cause if they're not kind of involved through the whole process. Here's just an illustration of that same load stability scenario. You'll see that this is old, but I put it in here intentionally, even though it was old, because a lot of these elements are not new, but people still are becoming aware of it, and it really just drives the point that there are ways to replicate the real world. There are things that you can do to be prepared. So, moving to vibration. This is, depending on your product, fairly kind of docile in comparison to shock. Shock has a lot of ability to cause damage to packaging and products. And the vibration is going to be different depending on what mode you're going. So are you on an airplane? Are you on a big jet, little feeder plane? Are you on a railroad? Are you in a country where the roads may not be as developed? So forth and so on. But just to give you a glimpse inside the truck to show you kind of that vibration, which you could argue that this is a few different elements playing at the same time, which is it's a key point to make. But you can see the water sloshing around due to the bumps in the road, the pallet rocking, causing some compression. It's not just straight down force happening. So you'll take a look at vibration, and even though I said it's docile, the shaking in itself is not all that significant relative to the other items. When you have vibration in combination with the other forces, such as compression, and you get this dynamic compression going on, that's when bad stuff happens. This picture here is actually in the back of a small parcel truck. Orientation isn't guaranteed. So you could be this little dinky package down on the bottom with all those others up on top. And it's going to bounce and compress. And if you're not aware of that, that could be a real problem for you. So that's kind of vibration and compression talked about there. Environmental. I think for the food folks, environmental is more in their wheelhouse, more in their general understanding of what we need to be prepared for. But I think, again, if we talk about some of these in combination with the other hazards, that's when problems are going to occur. And these are all just points to be made about how atmospheric conditioning can impact your packaging. Things that may be a little bit of a stretch from the food folks is what happens when you are in, say, an airliner, if you're shipping something overseas or what have you. Those are temperature and humidity controlled, but you get into a smaller feeder plane, something that's going into Jackson Hole, Wyoming, for instance, that's going to go into a small plane that's not temperature and humidity controlled, and you need to be prepared for potential altitudes of 20,000 feet. You start talking about tractor trailers that are sitting in the summer over the weekend when they're not moving. It's going to be the outside temperature plus. 140 plus degrees is not unrealistic. So kind of just to wrap up all those different hazards into one slide here, it is shock, vibration, compression, and atmospheric, all working independently as well as together, that you need to be thinking about. So where do those hazard elements exist? Let's take a journey. Let's walk through it. So I'm going to order some Twinkies from Amazon here, and we'll kind of just go step by step. So they're going to pick it up. The carrier is going to pick it up. And this here is just an illustration of an air delivery system. So they're going to pick it up. From that pickup, they pick it up to the factory. They're going to take it in a truck, small truck, to wherever. It's going to go to an origin. It's going to get sorted. It's going to get put onto a bigger truck with other packages going to similar destination. From there, it's going at the airport. And by the way, the airport gets some interesting hazards. There was just a study put out by Cal Poly out of San Luis Obispo, California, in conjunction with the FAA, to really shedded some light on the temperature and humidity associated with the airlines, but also some of the shock stuff that's going on the ground as they move the dollies and the carts on the tarmac. Because those little tugs and conveyor carts have no suspension. So it's just solid axle, pretty rough ride. So anyway, they're going to get on a plane, and the plane's going to take it to an international hub. From there, it's going to be taken off the plane. We're going to put it into a truck. It's going to take it to where it's going to be sorted into the smaller vehicle, and they're going to deliver it. So all those nodes signify touch points, signify areas and opportunities for one or all of those four hazards to exist. So if they're going to kind of go through a ground scenario, that's what this would look like. It would kind of reduce it slightly, take out some of those touch points. But nonetheless, those are all going on. So now if we talk about that's being picked up and taken to an e-commerce facility, a retailer, say Amazon. All that just happened is only on the front end. On their piece, they're going to take it, they're going to put it away. And in some instances, specifically for Amazon, if you don't have Prime, if you have opt for a long shipment, they may take a product from Indiana because they don't have the second piece to your order, put it on a trailer, send it to Phoenix, connect it up with your other product that you've ordered, and then ship it to you, so they're only shipping you one package. But the real key learning, at least for me when I was touring Amazon, is that's a whole nother cross-country shipment that's going on that I wasn't even aware of, that I didn't even know I needed to be prepared for. And it's in configurations of no orientation, potentially with no other packaging around it as it by itself. So there's a lot of interesting things going on in this arena here that is new to a lot of folks. So they do their piece. Then it goes out from Amazon to me at my house, and we're going through all these nodes again. So I really think if you think about kind of these touch points, and you think about kind of the particular supply chain, there's a lot of stuff going on. And if we dive into just kind of this e-retailer, Amazon piece a little bit more, we'll get into some of the stuff that I was talking about. Is you got it unloaded. So that's what this looks like. Stuff stacked up, commingled with other products. It's out of your control again. You need to be prepared for that. They break it down, Amazon breaks it down into 3 different scenarios: a small, medium, and large. Physical dimensions are dictating this. So small stuff goes into what they call the library, where they wheel carts around and place products on shelves. If it's a bigger item, it'll go out on the floor and be stacked up, depending on dimension and weight, up to 12 feet high. And then when it's ready to be picked, it may go on a conveyor, it may go on a cart or toted. I mean, here's a classic example of mixed things, random orientation, things to be aware of. And this is kind of that internal move that I was talking about, where they'll put it in totes or in other Gaylord bins to move them from facility to facility. Then ultimately it gets packed out and starts its journey. So some of the stuff that I've talked about thus far is about small parcel, which is, I think, applicable to almost everyone. But then we start talking about e-commerce, and, well, that's nifty. I'm not doing that right now. I'm in through the grocery. Well, believe it or not, Groceries doing the same thing. Groceries building mixed loads. Here's an example. We got stuff on its side. We got stuff upside down. You don't know until you start asking the questions about what's going on. Toured through Meijer, which is a grocery retailer in the Midwest recently, and they're floor loading. So they're taking product and stacking it in the back of a truck without a pallet, much like what we saw in the small parcel. So they're making these mixed loads. It is a reality for a lot of folks. Not to mention, if we start talking about outside of the U.S. and kind of less established networks. Now, these are somewhat extreme pictures here. I would say that those large carriers and large players are not the case. They're more kind of built infrastructures, but it's still emerging. So, not to scare you, but this could be going on. So, we talked about some of the fundamentals of packaging, the hazards to be thinking about, hazards to be worried about. Where do they exist? And now let's take all that and correlate it into a laboratory test. Like, how do we replicate this real world in a controlled environment? Well, I've harped on it a bunch here, but it's really about bringing that knowledge to the table earlier, asking those questions, making sure that you can apply this knowledge as a predictive tool in the design process. You know, and a question that often people are responsive to is, who do you want to see your test result first, you or your customer? Because if you're just shipping things out and not trying to correlate the real world with pre-shipment testing and evaluating these things on the front end, your customer is going to see what you might not want them to see in a damaged package. So if you're going to do some testing on the front end, there's varying degrees of testing, and it starts as simple as what we call a non-simulation test. And then it evolves from there. It evolves into a general simulation where we're covering broadly what happens out there. Call it the 80-20 rule. So we're covering 80% of the hazards at kind of 80% of the intensity. And then you can dive even further into what is called focus simulation, where you're analyzing your specific supply chain with your particular product and translating that data into the test so that you know for you it is specifically appropriate. Bear with me one second here. I'm being told that the battery is going dead. So at any rate, we'll move on, and if it conks out. So non-simulation testing is really basic in nature. Its intent is to do it as kind of a screening tool where you are evaluating two different packaging designs. It's not replicating when it said it was going dead, I didn't think it meant immediately. How about that? Let's see if we can see if it fires right up. If not, all right, moving on. So, non-simulation testing is something that's been around for a long time. Excuse me. It is traditionally what people think of when they think about like a 10-point drop test, the ISTA 1A. And it works good if you're trying to, again, compare two different designs against each other. When we get into general simulation tests, now the test elements are based upon information that was gathered from data. So it's more accurately replicating the real world. Some common examples are ISTA 3A or 4169 from ASTM. This is really one of the better places to kind of focus your attention if you're going to work on or do testing, because it is, again, covering a broad basis of elements. So if you really are having a particular problem, you want to dive right in and have a better understanding, again, focus simulation is where you should go. But these all kind of ramp up when we talk about non-simulation to general simulation to focus simulation. They ramp up in involvement and intensity and typically cost as well. So again, it's near perfect. I'm trying to make up a little bit of ground here. So we have all those testing methods for applying this information about the real world. But within those tests, there's individual things that you can do to replicate those hazards. So a shock can be done with a free fall drop. Again, it's not, I may have not said this before, so by doing a free fall drop, you're replicating a force that's happening to a package, and you're not necessarily saying that it's going to or has been dropped from this height. So it's just something to be cognizant of. We're really, again, trying to take this input from the real world and translate it into a repeatable test. And that can be done through many different means. Horizontal incline or a horizontal impact tester or incline impact tester will also create a shock force. Vibration, there's been a fair amount of work done out there on the different profiles and different spectrums. These are some of the profiles that are in the data depot within ISTA. And so when we talk about those vibration profiles and applying it to a test and making it realistic, this is a pretty good example of how we're combining those hazard elements to replicate the real world. So we got a truck. Below it, you'll see that's the vibration profile. So that would be pretty common thinking there. On the right is a picture of the inside of the truck, and we're going to try to replicate that truck moving down that road on a random vibration table, and we're going to do that by plugging in that spectrum based on that data and putting weight on top of that package to replicate that one that's right on the bottom that has other stuff on top of it. And we're going to vibrate that for up to 3 hours. So that it's just, again, trying to combine these elements together to get it as realistic as possible to get the best understanding. And then there's even elements within these procedures that are trying to account for some of the more unique things that are happening. So again, the FAA and Michigan State University did a study years ago where they were looking at leakers, packages that are liquid in nature that are leaking during transit via air movement. And they were able to come up with a test method that's part of the ISTA 3A procedure that challenges a packaging system for its seal integrity. And what it is you first draw a vacuum on the package. So that's what that chamber is there while on a vibration table. So that combination of under vacuum and being shaken yielded results that were in direct correlation to damages seen in the real world. So there's a lot of different things you can do in the lab to try to replicate the real world. And I know a lot of people will typically challenge me on the fact of, well, lab testing is great, but what if I just ship it out? What if I just ship it to California and get it back? I'll have a pretty good idea. Well, here's a great example of that. So if you have 5% damage rate currently, this shows you how many packages you have to send out in order to see a damage. If you're trying to replicate a damage, you got a problem, so you get 2 different or 3 different packaging designs. Now all of a sudden, I got to send 14 packages of each configuration to have a 50% chance of seeing that damage. Where in the laboratory, you're controlling those variables and you're able to get repeatable results. So you take that information about known hazards and what you think is driving that, put it in the test, and out comes some other stuff. ISDA is continuing to kind of enhance its testing through collecting more data. There's a kickoff to a research initiative that we're heading up, and it's really all about bolstering this information, the data that you have access to be able to have good test results. And these are some of the folks that are have partnered with us thus far, and we're getting endorsements from a lot of other folks on this. Again, trying to make up a little bit of lost time here. Some of their initiatives, actually their top 5 initiatives right now through this consortium, is to understand damage numbers a little bit so you can rate yourself, you can compare yourself. So I'm a food manufacturer that focuses on dairy. I have 5% damage. Am I really bad, really good? Where do I stand? And so that's one of their initiatives. Drilling down and standardizing the e-commerce world is something that they're looking at. Getting more information on other areas, other emerging markets and countries is another thing. Just overall enhancement of procedures to provide confidence levels so you can eliminate packaging. So instead of achieving a pass-fail result, you can achieve a pass. So you've surpassed the intensity level by 25%, which allows you to then kind of back out some packaging or product. And then load stability, as you saw in the illustration of in the back of a truck, load stability is something critical, especially for those folks that are selling into retailers. So we're going to apply this knowledge as a predictive tool, and how can we do that? So I gave a lot of different examples, a lot of insights into the supply chain, the different supply chains, but there's a lot of folks out there that can help facilitate drilling even deeper, and you should leverage those people. You should leverage your internal partners to answer those questions that we had earlier on of like how many touch points, where's my package going, is leaving my control, so forth and so on. You know, the logistics folks, if you're in the packaging arena, there's other folks outside of you in the logistics supply chain, warehouse. All these people have great knowledge on that. Inversely, if you're in supply chain or warehouse or manufacturing, the packaging folks could likely help you through this endeavor, as well as there's always external resources such as ISTA and suppliers who can shed light on the different aspects of the environment. There's plenty of research that's been done throughout the years. There's a big collection of over 800 papers and presentations in our technical library if you wanted to mine some of that data. Again, there's just lots of resources and avenues out there if you're asking the right questions and looking from the right spots. And you can gain some education through ISTA on transport packaging, growing or deepening that knowledge base in that specific arena is something that we certainly can help you do. So, in closing, it's really critical to ask questions and understand your supply chain. You need to kind of create that linkage between what's going to happen to the conversation early on. You know, I personally included it in my design briefs when I was in the consumer goods role. The simple questions of, is this going to go e-commerce? Is it not? Could it go upside down? Is it going to go outside? What country is it going to go to? Is it going to be sold globally? Is it going to be launched in the same format in all places at the same time? So forth and so on. So you can certainly leverage that knowledge, contrast it against the product's susceptibility. So we're back to that steel bar and light bulb example. Kind of compare the two to get to the optimal packaging design. And ultimately, being prepared alleviates under and over packaging, which equates to cost avoidance. So I think we've done it. I am available for questions either today or the rest of the week. We have a booth here. It's 528 in the East Hall, the Lakeside. Feel free to stop by and we can discuss your particular questions or problems or issues. As always, the International Safe Transit Association is looking to better the industry, and we're here to help. So we can connect you to either people who have a similar problem or someone who may be able to help with your unique problem. We can connect you. So with that being said, I will close and thank you very much for your attention.